Welcome to all of our Incredibuilders to the next edition of Level Up with Incredibuild. This is a webinar series designed to educate our users with tips, how-tos, best practices, use cases, and other helpful content. And today falls into that category of other helpful content. The topic is C++ typical typos, which I think I typoed a few times. I was looking on our customer forum and I typed typica without the L, type typos. So anyway, that's the title of the talk today. I am Jim Schilt. I'm the head of community at Incredibuild. If you've not already joined our customer forum, go to community.incredibuild.com and you should be able to join right there. Our speaker today is Incredibuild's very own C++ developer advocate, Amir Kirsh. Amir, would you like to do an intro of yourself, who you are, some of your background?
The intro would come on the second or third slide, so we would wait for that in a moment.
Perfect.
Maybe the next slide, I really don't remember. Anyhow, thank you, Jim. Let's talk about typical typos. So I guess the audience came here to hear about C++ because we're going to talk about C++ a lot, and mainly about those small things in C++ that you have to do right. So let's start. So here it is. It's on the second slide. I'm a lecturer at the Academic College of Tel-Aviv-Yaffo, a member of the Israeli ISO C++ national body, co-organizer of the CoreCpp conference and meetup group, and a developer advocate at Incredibuild. Most probably the audience here knows about Incredibuild, but for those who do not, for some reason, if you are suffering from slow builds, it's not just waste of time. It actually affects your development cycles. It reduces your secureness, the way you develop. If you have to wait for each build for more than a few minutes, then your productivity is being hurt. So talk with us if you have this problem. This was the last plug in this talk. And now we go to talk about C++ typical typos, which are in this talk common errors that relate to bad use or implementation related to types. Now, it would include bad design, inefficiencies, undefined behavior, actual bugs, or some compilation errors. So compilation errors are also important. Usually when something declines to compile, you say, okay, the compiler would tell me I would fix it. And still, it is important to understand what was the problem, because in some cases, and I see it with students, and the same would be with juniors, is that when you get compilation error and you fix it without understanding the actual problem, maybe now it compiles, but you actually put in a new bug. So you actually have to understand what was the problem, why the compiler was complaining, and we're going to meet all of those. Just before we start, pay attention to compiler warnings. So some of the things that we would see here, somebody can say, but you know, the compiler would warn me. That's good, but you have to pay attention to compiler warnings. Same goes also with static code analysis tools. You most probably have to or should use proper static code analysis tools in order to avoid some of the issues that we would see down the road in the coming slides. And best practices. So if you follow the best practices, again, some of the things that we would see here would be avoided. On the other end, you know, the best practices tend to contradict each other. So in some cases, you would find something in one best practice, but the other way around saying quite the opposite in another one. So we have to take that also into account. Also, before we start, some slides would be annotated with a skip sign, meaning that we may need to skip them if we do not have time. So don't feel bad if we skip on them. It is in purpose. And last final note, it is a game. So treat it as a game. You are requested to count your own points. And for that, you must submit your answer, and submitting would be through a poll. There would be a poll for each question, and only if you answered the poll, you should count your points, and you should count points only if it fits my own answer, which means even if you think my answer is wrong, my answer gets the points. And there is no prize. The prize is your pride, being first, saying, yes, I got 20 out of 20. Okay, and we will let you say that aloud. Let's practice a bit. So let's try it. Okay, you should not count this one. Okay, this one is just to warm up. What is the value of I in this code? We have a main, okay, and in the main we have a single line of code saying int I equals I times 0, and the answers are, wait a moment, in a moment you would get the poll, but the answers are: A, it's undefined behavior due to bad initialization. B, it says almost the same, but I think this one is for Brits, initialization with an S. And C is also very similar. Well, this question tries to see whether you are American or a Brit, maybe maybe an Aussie. Anyhow, let's have a poll. Jim, if you can open our first poll. So please select your answer to the first question. What would you get here? Well, it is undefined behavior. You cannot use I when it is going to be, it compiles or it may compile, but the result is undefined behavior. And then the question is, okay, is it A, B, C, or D? Let's go for that. Okay, so you can see now the answers. Most of you are Americans here, I see, with a Z and behavior without the U. This was a very special question. Now, the next one would be on C++. I mean, this is C++, but all answers were quite the same. Okay, I think that you are ready. Let's go. So let's start. First question. What's wrong in this code? And in order to focus you on the problem, let's take a look at this line. In this line, we have a pair. We want to iterate over all values, all key and value in the map over all pairs. And we do that with a const ref to the pair, and we print P either with print in the key, the first and the second. What's wrong with this loop? Is it the dangling pointer you see there, inefficiency, potential leak, or a compilation error? Let's have a poll. Jim, would you like to open the poll for this one? And here it is. So do you see here a dangling pointer, some inefficiency, a potential leak, or compilation error?
You want to give like 30 seconds on these, Amir?
Yeah, I think that we would wait for a few more seconds and we can share the results. Let's see what are the results. And the results are, most of you see here inefficiency. And in fact, there is inefficiency here. This is the correct answer. The problem here is inefficiency. What is the inefficiency? Well, anybody can tell something, maybe in the chat? What is the inefficiency that you see here?
If you'd like to come off of mute to answer to, just raise your hand and I'll take you off.
If anybody wants to open the mic, just raise the hand. So I will tell you, the inefficiency is that actually a pair coming out of stud map or stud unordered map is a pair of const key and value and not of key and value. So here, because we get out a const key, we cannot get it by ref because it's not the same type. So there is a new object being created. The compiler says, okay, I can do some casting here, creating a new pair of a key and value, and the const key can be copied to a key, because even if you change now the key, it's a copy, and there is a constructor for pair, creating a pair of key and value from a const key and value. And this constructor is being called. And it means that for each iteration, we create a new pair, and inside this pair, we create a new key. We copy the key and we copy the value. So we would call here the copy constructor of the key and of the value and of the pair, which is quite inefficient. And the reason again is because we just do not use the proper type. Is there any other way to avoid this inefficiency rather than adding const here to the k? Well, it is. There is. And the proper way to do that is to use auto. So the first option is just, to use the proper type. The proper type is a pair of const key and value. But the better way would be just to use auto, and auto would deduce the proper type, and deducing the proper type allows us to avoid this inefficiency. And this is, by the way, one of the recommendations or one of the points in favor of using auto. Even nicer, we could even do a for loop that use structure binding, and then we can get out the key and the value out of the map into actual key and value variables. So this is also another possibility. Related to that is a question in Stack Overflow on how much auto is too much, and the answer is use auto. Auto has many advantages. One of them, it deduces the right type and avoids unnecessary casting, which might have unnecessary copies, redundant copies. The Google guide, style guide also says use auto in some cases, maybe for this one. So yeah, auto would be the right way in this loop. Next one, what's wrong in this code? Well, it resembles what we saw before. We have a print. Now here we have the auto in the loop, but the question is on the signature of the function. The function gets a map, and we get a map as a ref, const ref to a map. And the question is, what is wrong here? We want to loop on a map and print the values in the map, or the key and the values. And the answers are const issues. We have const issues here, or should use forwarding reference. Maybe we do not use forwarding reference somewhere. The code is not generic enough, or there is some kind of a bad style. You can cast your vote now. And we will let you 10 more seconds. So in about 10 seconds from now, we will share your voting, and we will discuss what I think is the problem here. Okay, I see here quite a spread. So nobody sees a bad style here, but we do see here const issues. I see that we use const here. I think const is used here correctly. Should use forwarding reference. Well, there isn't any place here yet to use forwarding reference. And the last one, not generic enough. Yeah, I would go with not generic enough. And the question is, what is not generic enough in this piece of code? Well, the problem is that a map has a third template argument, a third template parameter, which is the comparator. Now, usually when we use stood less, it means that we want to sort the map. The map is sorted from down up, from the smallest to the biggest. But we can provide any other comparator. Now, if we go with another map that has another comparator, this map would not be able to go into this function. because we expect here a specific map with key and value, and once that we do not provide the third template parameter, it means that we expect here the default, which is std-less, which means that this one would not go to print, even though it's a valid map. So, and the computation error that we would get is a mismatch between std-less and std-greater. So it's not generic enough. How can we write it better? Well, we could say that we have a map for key and value and additional args. By the way, why additional args? Why not just an additional single argument? Well, because there is also an allocator. So suppose somebody wants to give another allocator for the map, which is not default allocator. Here, we also accommodate this issue. So we have some kind of a more generic one. Another option is to say, you know what? We want to support any kind of a mapping container. And a mapping container should have a key and a value using a template parameter is called. A key, which is kind of a class, and a value, and additional arguments, which are in our case, might be comparator and allocator. Now, there is a problem with this one. And the problem with this one is that this one is too generic. We had before something which is not too generic, which is not generic enough. And now we have something which is too generic, which is even greedy, which means it would take any template with 3 or with 2 or more arguments, even if it is not a map, which is not good. So it's too greedy. It's too greedy. And it might be that we want to add a requires clause in order to make sure that we actually get a mapping container. And we can do that. Let's go for the next one. What's wrong here? We have a print pair function getting an auto argument. Let's assume that we use auto here because we're using, let's say we're using C++20, which allows us to use auto on the parameter, on the argument, and we print the first and the second of this pair. What's wrong? And the answers are dangling pointer, if you see inefficiency, a potential leak, or bad design. What is the problem? You can cast your vote, and we would discuss it in a moment. Okay, 5 seconds.
We need voting music, Amir. We need voting music. You need to like hum a tune while people are voting.
I didn't prepare any voting music. But we can, I think, share the results. So what do you see here? Most of you see a bad design here, a problem with the design. Well, actually, there is a problem with the design here. And the problem here with the design is that, well, the problem is to begin with the language itself. There is a language issue, some kind of a language accident, having first and second as attributes, as fields, as data members, and not functions. I mean, when I approach first and second, well, it means that P is a pair. Well, what would happen if P is my own implementation of pair, and I want, for example, to have a lazy pair, and my lazy pair as a first, and only when you call second, I calculate second when you call it. Well, if it is members, it would be much harder. We can do that, by the way, with a proxy class. There is a link down below showing how we can have a lazy pair in which you initialize the first and you calculate the second only upon call to the second. But it is much harder. Suppose that first and second would have been functions as it should have been. Things would be much better, easier to implement if you want your own pair. Suppose that you want a lazy pair, for example. So this is one problem, a bad design in the language itself. The second issue is it is too generic and not generic enough at the same time. It is too generic because I'm taking anything. And it is not generic enough because I'm assuming that I have a first and a second. And what about tuple, for example? Suppose that I have a tuple with two elements. Now, tuple do not have first and second, but tuple do have the ability to access its first element and its second element. So in a way, I'm getting anything, but actually, I'm not supporting the types that I could have supported, like tuple. So maybe if I would write it as get 0 position of P and get 1, the first position of P, this would work for both a pair, a tuple, and a stud array. Now, it might be that I want to narrow the auto here for being only something that has 2 elements. Well, I can do that. I can do that with, for example, having a concept, and this is a C++20 feature, like, for example, a concept for pair, saying that a pair has a tuple size of value 2, and you should have a get for 0 and a get for 1. So if these do not compile, it means that the type P is not a pair. I mean a pair that we call it a pair. We here define what we see as a pair. And now, instead of just getting auto, we get a constrained auto, which is some kind of like a sphinx constraint. And then we know that we got something that we can call get 0, get 1. So this would be the proper design. Let's go for the next one. Are you ready? So suppose that we have a 0 initialize all, and we get some kind of container as auto. And we want to loop on the container and get all values from the container by reference. And then we use value initialization. In this case, the empty brackets, the empty curly brackets here mean that we want to 0 initialize. I mean, if this one is an object, then we would call it empty constructor. And if it is a number, then we initialize it to 0. If it is a Boolean, then we want to initialize it to false. And the question is, what is wrong with this loop? And the answers are, well, the first auto, this is the first auto here, should be auto ref ref. Or maybe B, the second auto should be auto ref ref. Or C, both. Second auto should be by value, sorry. And D says that first auto should be by value. What do you say? What is the problem and what is the fix? Let's go for that. It's quite complex here. One of the auto is not so right. Which one of them? And how should it be fixed? Let's give you 5 seconds. And I think that we would reveal the results in 1 second from now. Let's do that. Let's reveal the results. What do you think? Well, most of you say B. B says that the second auto should be auto ref ref, and that's correct. Yes, the second auto should be ref ref. Why? Because, well, the first auto says I'm getting the container as L value reference. That's fine. The second auto, well, here we actually want to get forwarding reference, also known as universal reference. The reason is that if the container is a vector of Booleans, then the Booleans doesn't get out as Booleans, it gets out as a proxy to the Boolean as a reference bit, which is returned by value. If you want to read more about vector of Booleans does not hold Booleans, mainly for efficiency reasons. It actually holds bits. And the bit cannot get out by ref. Instead, we get a proxy. And the proxy cannot be achieved, cannot be retrieved and handled as a reference. So the correct way is to add ref, which is not our value here. It's a universal forwarding reference. And then we do support also a vector of Booleans. And by the way, when you go to ranges in C++20, this gets additional examples where auto ref ref is the right choice. Beware of specialization, by the way. Vector of Booleans is also considered as a language accident, which means, oh, maybe we should have avoid that or implement that otherwise, but we would not discuss that now. But if we are talking about Bureau of Specialization, let's take the next one. In this one, we have here a template class called foo. And we have for foo a specialized version for a foo of pet. So let's take a look. Foo, the primary template, the base template, prints something, okay? And the print of foo of pet prints, I'm a pet, just prints pet. Now pet has a derived class called dog. And here in main, we have foo of dog calling print. And the question here, what would this main print? And the answers are, oh, it would print something because I would reach this print function, or it would print pet because I would reach this print, or it would print dog. Well, I cannot explain how it would print dog, but this is one of the answers, or program doesn't compile. This is the time to cast your vote. What should be the printout of this main? Does it compile? If it compiles, what does it print? And we will give you 10 seconds to think, to guess if you want. It is okay if you are guessing. What would be printed here in this example? 5, 4, 2, 1, and let's see your votes. Okay, most of you say A, which is the correct answer. And the reason that it would print something and not pet is that specialization doesn't work well with inheritance. Well, a pet, yes, a pet is the base class of a dog. A dog is a kind of a pet, but specialization is looking for exactly a pet. By the way, this is some kind of type ID versus dynamic cast. Type ID checks that my type ID equals another type ID, and in some cases this is wrong, and you have to use dynamic cast. And here we might have used requires, C++20 requires, or we can use Finae, but specialization here should be a bit different. Same results, by the way, if we go with a pointer, and here we have a dog pointer, same result, nothing changes. So there is a way to improve that, but we would not do that right now. What's wrong here? Well, this is some kind of, let's see what we have here. We have a class, okay? And the class holds only RAI objects. Let's talk about what do I mean when I say it holds only RAI objects. RAI stands for resource acquisition is initialization, which means that I hold here objects that manage their own lifetime. They get alive, they allocate maybe things, but when they get dead, when they are dead, they deallocate. So all objects that I hold are managed. Now, I have a default empty constructor. For some reason, I want to increment some static counters, so I have a copy constructor, which actually calls all the copies and copies all the members, and other methods, but no other constructor and destructor. And that's okay that I do not have any destructor. Why? I don't know. I think it is okay. So what's wrong here? Do I have here a potential leak? Maybe it's not good that I do not have any destructor. I mean, I don't have a destructor. Compilation error, dangling reference, or inefficiency. So you can vote now. What's wrong with this class? I add a copy constructor just because I want to increment some static counter. I do handle the copies. I mean, in the copy constructor, I actually copy, but that's it. Should I add something? Maybe I'm missing something. So let's give you 10 seconds from now. Take another look at the code. Jim, I think music for the voting would work. And we see here that most of you are saying a potential leak. Well, Actually, there isn't any leak here, because when I say that all my fields, all my data members are RAII objects, I mean they are managed. So the problem here is inefficiency. And why do we see here inefficiency? Well, because I have a copy constructor and I didn't default the move operations. Now, when I have an RAI object, it might mean that I have here a vector, maybe a few vectors, a string, a list. Now, in the copy, I'm copying, that's fine. But suppose that for some reason I have an object of type my class, which can move. It would not member-wise move, it would not call the move operation on its members, because my move is implicitly deleted. So in order to have it right, I have to go to the rule of zero, which means that you should either not implement any constructor. I mean, from the copy and move, don't implement copy, don't implement assignment, don't implement destructor. All fields are managed, don't implement any of the 5, be on the rule of zero. But if you are not, then you should default the move operations. Otherwise, for example, if I put my class in a vector, any pushback would copy instead of move. And here I'm copying when the capacity is exhausted, and I have to move the elements from the older location to the new one. I would not move because I don't have move, and I would not move any R value, etc. So make sure either to implement your move operations or to default them or to be on the rule of zero. How to avoid it? Well, the best way to avoid it is to be on the rule of zero. And in order to be on the rule of zero, you can take up the operation of, well, I want to count the static counter. Well, you can count the static counter in a base class, which means that the base class would not have any destructor. It would just, or maybe the base class doesn't have any member. It just have the static member. But in your own class, which actually in this case inherits privately from a counter, my class counter class, I would still be in the rule of zero. So this would be the best approach. Let's go for the next one. I have a class, let's call it my class, and my class does have a move constructor. This is a signature of my move constructor. And let's assume that in the move constructor, I actually implement a good move operation. So what's wrong here? Well, I don't have enough code to look for something wrong. And again, the move inside is implemented correctly. So do I have here a dangling reference or inefficiency? Or maybe I'm missing a const, or maybe something here would have compilation error. Let's have the poll, and you can cast your vote on this one. It's a very short piece of code. We just have the signature of the move constructor. And I'm telling you that something in the signature is bad. What's bad? Maybe something that would create dangling reference, inefficiency. Am I missing a const qualifier somewhere, or maybe compilation error? Let's give you 5 seconds. I know it's not much time, but you should think fast or guess. And the results are, most of you are saying that we are missing a const, and no, we do not miss a const, because the move constructor should not have a const on its parameter. Otherwise, I cannot move from a const. So no, don't add const here. The problem is inefficiency. And the inefficiency is hiding. It's hiding with actual keyword that is missing. And the keyword that is missing here is no except. Move constructor should have no except. And if you do not put the no except on the move constructor, it means that your type thinks that it has a move constructor. Well, it has actually, but in some cases, the move constructor could not be used because in some cases, I can use the move constructor only if it doesn't throw an exception, or if it says it would not throw an exception. And the best example is when a vector exhausted its capacity and the user calls pushback, and the vector needs to be enlarged. So I need to allocate new capacity and either move or copy the old allocation to the new one. And the question is, should I move or copy? Well, it's better to move. Now, if I move, it might be that I move something, and then if it throw an exception, I cannot move it back because maybe it would again throw an exception. And then if somebody, if the move operation threw an exception during the move, I have an old allocation which does not hold the entire vector because something was moved already from there, and a new allocation that also doesn't hold the vector elements. So it means that I wanted to be enlarged, but currently I don't have the vector. Something was messed up. So I don't have any other choice but to copy. On the other hand, if the move constructor says that it would not throw an exception, it means that I can move the elements from the old location to the new one, knowing that the move would not throw any exception, which means that all the moved elements would be able to move, which is the right choice. So in most cases, I would say in all cases, move should not throw, and because it should not throw, you should say no except. And then you can use move in context where it cannot be called if it may throw an exception. And you have here, by the way, reference to Stack Overflow talking about that, and you can actually implement a small example showing that, yes, if you forget the no except, you would actually have a performance loss, a performance penalty. So if you want to see, you would actually have here in this example calls to the copy constructor instead of calls to move when you push back to a vector. Let's go to the next one. There is some kind of saying since C++11, if you want to copy, pass by value. Let me explain. If I want to copy, instead of getting by reference and then copy the reference, I mean copy from the reference, I can get by value, which means, okay, I just already got the copy. The compiler went through the copy constructor because I got by value, and then I can move from that. I can steal from the copy because I know this copy is mine. It would not be used at the end. It's a local variable. Now, what I earn here is that if the object that you were sending is an R value, then there would be optimization and a copy would not be created. And then I actually move from the actual R value without any copy. That's good. And if it is an L value, then the L value is being copied, and then I move from the copy. So it actually seen as a good advice. And my question is, well, if it is a good advice, so what's wrong here? And the answers are, oh, you have a dangling reference here, or inefficiency, again, inefficiency, potential leak, or compilation error. What do you see here in this example? And in this example, again, we get the string by value because we want to copy it. We want to copy it into some kind of a set of strings. So instead of just copying, we get by value, and then we move from the copy. We move from the value. Please cast your vote. Is it a dangling reference? Or maybe inefficiency, potential leak, or compilation error? Let's give you 5 more seconds. And I think that we can share the results. It was short 5 seconds. Okay, so most of you say inefficiency. Maybe you saw already that inefficiency is a star in the questions. And you are right, there is a problem here. And the inefficiency here is that, well, the advice of if you want to copy paste by value is not always correct. And the better advice would be handle the R value and the L value separately. So you would have a separate call that would be treated as an L value, and the separate one as R value, each one with its own code. What's the problem here? The problem here is that when you call insert, you actually create the copy, even if you do not need that. I mean, insert in a set may find that, oh, I actually have this value in the set. So it means that I created the copy, even though I'm not using it. And if I would have created two functions, one for the L value, one for the R value, I would have achieved here better performance. There is a talk by Howard Innant on the topic. And the idea is that pass by value might be okay for some cases, but take it with great care. Here, the alternatives could be either implement one for L value and the other for R value, which would be better, or you can go with the forwarding reference style, saying, you know what, I'm taking both the R value and L value with a template, saying, okay, just get a T of double ref here, which is not R value. This is a forwarding reference, and then I'm using stood forward. Both achieve quite the same. If we go with a table comparing the alternatives, well, the by value would copy if I go with an actual L value. This is costly. If I compare it to all other cases, in all other cases, no copy and no move. I mean, if I get it as a const ref, nothing happens. I just took the const ref. Maybe I did copy inside the set, but suppose that it was an existing item. This slide talks about an existing item. So all these cases I do not copy because it is an existing item. And you can see that if I just take a const ref and this is my only option, then I copy for the R value, which is not efficient. So the best case would be the options that we saw in the previous slide. Yeah, this should be. Okay, let's go for the next one. It's a very short piece of code. A very short piece of code. What's the problem here? A person P is John. Oh, constructor is not explicit. A potential inefficiency, bad use of char star, or a potential leak. What is the problem? No need to go through the code line by line. It's a one-liner. So what's wrong with John? Let's give you 5 seconds. John, are you a person? Yes, I'm a person. So what's so bad with you? Do you see the problem? Okay, let's see your votes. And the results are, most of you see that, yeah, constructor isn't explicit. I mean, well, this is the first time that we saw this answer. It must be relevant. Yes. When should we have an explicit constructor? Well, we should have explicit constructor when the argument that we take is not the full state of the object. And the reason here, well, we do see here that person is getting a char star, and it means that because of the equality sign and not taking it with parentheses, it means that the constructor is not explicit. But it also means that if I call, for example, in this case, a function that expects a person, I can send to it a char star. And a char star is not a person. I prefer to make sure that I actually got a person. Maybe this is the name of the person, but it's not the full state of the person. Now, if you go to vector, for example, vector cannot be initialized with the 7 like that. It can be initialized only with parentheses. And the reason is because we do not want to get 7 and create a vector. Like, for example, when you call foo, we do not want to call foo with a 7 and it would not compile because the constructor of vector is explicit. On the other hand, the constructor for string is not explicit. Why? Because hello is the full state of a string. So in a way, when you think about the constructor that actually initializes a class, think, do you want to be able to have implicit casting with this constructor? And if the answer is no, I do not want implicit casting from this value, make the constructor explicit. Okay, next one. What's wrong here? Well, we have here foo, and the foo has a pointer PTR, and we have a getter which returns the value of the PTR, and we also have a foo1, a const function that puts something in the PTR, and another one that returns the PTR by ref as a pointer, and another one that increases PTR. Now assume there is a good reason we do not use smart pointers here. So that the answer is, oh, the problem is that you do not use smart pointers. No, assume that we actually for some reason need to use here pointers. Well, maybe the code doesn't compile, or maybe PTR should be mutable, or maybe the code breaks logical const, or it breaks physical const. What do you say? Do you think that the code compiles? And if it compiles, is it a good code, or maybe we should change something? Let's give you 5 more seconds. And let's review your votes. Okay, so most of you say that maybe PTR should be mutable. Well, this is a question of design. Maybe, I don't know. I mean, I'm not sure that I want to change it, or should I? Well, here I think that we go with my answer, because the mutable answer, somebody can say, okay, this should be a better design, or maybe I should not change PTR in a const function, so maybe it is not mutable. Well, I go here with code breaks logical const, and I would explain. The code compiles, and the last 2 compiles because the method is not const. I mean, okay, get2 says, okay, I'm returning PTR. By the way, this is also a smelly code. Why? Because get, here I have a getter that returns data member by ref. Not so nice. Don't do that. But let's focus on the first 2 lines. Here it compiles, but I mean a const function that actually returns the content by reference. And here I actually change the content. And the reason that it compiles is because the compiler protects the physical constants of the object. And the physical constants of the object in this case is the address, is PTR itself. PTR, the address. And because I do not change the address here, the compiler is fine. But I'm not. I'm saying, well, you do not change the address, but you actually change the content. And I don't want you to change the content. By the way, even if you had mutable here, the code would still be smelly. So yeah, the mutable answer is not right. Why? Because if you had mutable here, it means that I'm okay in a const function if you're changing the address. And still, these 2 are smelly in a way that it's a const function. Why do you return the actual value by reference? And it is the programmer responsibility to protect the logical constness of the class. And in some cases, you do see bugs of that. So logical const versus physical const, this is something that you have to know of. We would not discuss const iterators. We would not discuss const smart pointers here. We would even not discuss forgetting constant methods, which is also something that you should be aware of. Put const, because it widens the possibilities. Remember that there is also const expression when you can use it. Let's go for the next one. What's wrong here? Oh, this is quite of a complicated code. Let's try to explain what we have here. Well, what we have here is, before we see the answers, what we have here is some kind of function called, the name of the function is get or default. This is the function, get or default. Now, get or default, the function get or default returns the mapped type from a map. The mapped type is the value given the key. So you're giving me the key, and I would return the value. The thing is that maybe in the map you're providing me with a map, with a key, and with a default value. So if the key is not in the map, I would return you the default value provided. So you would actually get or the value that is either the value that is in the map or the value that you provided as the default value. And here the implementation is quite simple. I'm looking in the map whether the key is found. If it is found, then I return the second, which is the value being associated with this key. And if the position is the end, it means that I didn't find the key and I would return the default value. And for me, currently, it seems like a perfect implementation. I mean, you provide the map, you provide the key, you provide the default value, and I would return either the default value if I don't find, or the value if I do find. So what is the problem? Maybe the map can be empty and then you have a bug, or maybe there is a dangling reference somehow, inefficiency, or the code is too generic. What do you say? Because, you know, it seems okay, I think, or maybe there is inefficiency or some dangling reference, or maybe we have a problem if the map is empty, or maybe the code is too generic. So let's give you 5 more seconds. And let's review the results. Okay, all of you say that the code is too generic. Yeah, it's quite generic in a way, but that's not the problem. The problem is that we may have here a dangling reference. Now, this example comes from a talk by, I would recall his name, from Facebook in CppCon 2017. And this is one of the recurring bugs at Facebook. The talk was about recurring bugs at Facebook, bugs that, oh, I have again this dangling reference that we just fought, and we thought that we eliminated. It came back again. So where is the dangling reference? The dangling reference is, if I'm calling this function, get_default, and I'm getting back a reference, a const reference, and I'm holding this reference as a reference, because I know this is a reference, so I know it is still alive. It might be that it is not. How come? Because maybe the default value was created from a temporary. Now, if the default value is created from a temporary, like for example, we call getter_default, we are looking for picotaro. If we do not find any picotaro, then please bring me back a pineapple. But the pineapple should come back as a string. This is not a string. So the compiler would create a string as a temporary object. But we try to hold the string by reference, and the reference lifetime is not extended here. There is a rule of extending the lifetime of the temporary. It happens only if the temporary is being created on the same statement. And here the temporary, if it is directly created into the variable. Not if it is created in this statement, but not directly into the variable. So the lifetime of the temporary is not being extended, and we actually get here a reference to an object that is still alive when we are in this statement, but on the next line is not. So here, str is being dead, and we try to use a dead variable, a dangling reference, in fact. So this example came from, note, by the way, that if you are using address sanitizer finds this issue. So use address sanitizer, because you know these issues are those that work on your environment. You say, but it worked, and then it crashes in production. Because usually when you use a dangling reference, well, the reference is still there, and the value is still not, yeah, it's dead, but when I go to the memory, it was still there. In some cases, and in other cases, it does not. So it's undefined behavior, and it's the cases where you get the crash. Usually, when you don't want a crash, I mean, do you want a crash at any point of time? Yes, in testing. I do want it to crash in testing, but usually these kind of things would not crash in testing, you know, to irritate you, to bring the actual bug in production. So address sanitizer would catch this issue. And it is from Louis Brandy, talk in CppCon 2017. If you go to this, to minute 14 and a half, this bug is there. Now, there is a way to solve the bug, and the way is to return by value. The problem is that returning by value is a bit costly. I mean, I just create a copy, even if I return the value from the map. In some cases, I return the value from the map, and I know the value is still in the map, and maybe I'm single-threaded. If you're not single-threaded and the map can change, you are still in the same problem. So you may want to think maybe you want to return by value, which can be a good solution. Okay, this is what they did in Facebook for this issue. Or you may want to still return as a const ref, but delete the overload. I mean, you say, okay, I delete the overload of getting the mapped type as an R value, which means you cannot send me an R value because I deleted this option. Oh, you want to send? First create the object, then call me with an L value. And this can fix the issue. They didn't take this option in Facebook because, well, it might be that you do get the value from the map and you hold it by ref, and then the map is being changed. So they preferred this solution. By the way, Brandy Lewis in his talk, he says that they did that, and they add, of course, a comment saying, oh, please note that. And then, you know, a few months later, a developer comes, he doesn't read the note, and he says, oh, why should I return it by value? It's not efficient. And he adds here the ref. So this is a recurring bug. Even if you have the comment, read comments. Okay, so let's keep the issue, but we have the exact same issue with our value shell PTR that returns, and we get it without actually creating a new shell PTR. I will not discuss that, but Brandy Lewis is discussing that in the same talk. So let's go to the next one. What's wrong here? We have 3 loops. Let's take a look at the loops. Okay, the first loop, the first one, is looping on a string, a temporary string with hello. So I'm creating a temporary string, and I'm looping, hopefully, on the characters in the string. Yes, you can loop on the characters of a string. I mean, string is iterable. String has begin and end, returning iterators. The second one says, you know what, I would not loop with a char as char by value. I would loop with a const char by ref on the same idea of a temporary string. And the last one says, I want to loop with char C on person John. Do you remember John? Now he is explicit. I create here a person, and then I call name. I'm asking, can you please give me back the name of person John? And the question is, what would go wrong with any of these? These are the answers. Let's take a look at the answers before the poll. A, all 3 loops may be using a dangling reference. Or B, A is okay, B and C may be using a dangling reference. Or C says that A and C are okay, but B may be using a dangling reference. And the last one says that A and B are okay, but C may be using a dangling reference. So the question is, which of the loops is bad? 2 of them? 1 of them? Which one? This one is important, I would say. I mean, you take a look at that and you say, well, I didn't think about that. Well, you know, maybe I have something like that in my code. Which one of the three, or two of the three, or maybe three? Because answer A says all three loops may be using dangling pointers. Let's give you 10 seconds. I think you have to think about that. Take a look at the loops. Try to hear the sound of the dangling reference whispering there, moving with the wind. Okay, let's take a look at the results. Okay, it splits between B and D. Some of you say that A is okay, but B and C are not, and some say that D, the problem is D. And the answer is D. The answer is that A and B are okay in this case. I will explain why in a moment, but C is not. And the situation is that when you loop over a temporary, and here a low is a temporary, the temporary is being bounded to a variable that extends its lifetime. So this is being created directly into the loop variable. I mean, not into C, but into a variable that holds the thing that we loop over. The same thing happens here. The problem here in the third one, in the last one, is that if the lifetime of the temporary, you can see that person John is a temporary. I mean, person John doesn't have a name. Well, it has a name, John, but the object itself doesn't have a name. So we have here a temporary object, and the name function returns something which is still alive, but not on the next line. And the next line is when we loop over it. And the lifetime of person John are not, the lifetime is not extended. And since person John lifetime is not extended, it means that person John would be dead. And we are looping on a name which can either be, by the way, if we create here some kind of allocation or string, but most probably we return a const char star of the actual name of the dead person. So it would be running on dead allocation. And these two above are okay, but you may want to rewrite them as well. But they are okay. So you have to remember, if you loop over a temporary, that's okay. You may want to change it, but that's okay. If you loop over something that results from a temporary, like in C, that's not okay. Let's go for, and here I explain that the loop, for each loop, is being, by the compiler, is being traded for, okay, let's create the range, and here lifetime is being extended for when I create a string, but it is not when I create a person, because person John is not the direct assignment. So the lifetime is being for, oh, if I create here temporary, then the temporary lifetime would be extended, but no, the temporary is not being assigned to a variable. Something else is being assigned. Okay, that was the previous one was important. What may go wrong here? We have here a foo function expecting a base. We have some kind of a derived. I will tell you that the derived is being derived from the base, as it sounds. And we have a foo function expecting a derived. Now, for some reason, I need to call foo and cast it to base ref. Maybe the reason is that I have two foo global functions. One that is expecting a derived and one that is expecting a base. And here I want to call the base. So for some reason, I want to call foo and send it a D and want to make foo think that this is a base, which is fine. But there is another problem here. Maybe base might be abstract, and then we have a problem. Or maybe we have a runtime bad casting. Or maybe we may have a compilation error or an infinite recursion. What might be the problem? And again, the question here is what may go wrong. I mean, it may work, But in some case that you cannot expect here, you may get something wrong. And the question is, what may go wrong? Maybe base might be abstract and then something would go wrong. Or maybe you may have runtime bad casting or compilation error or infinite recursion. Please cast your vote. And I will give you 10 seconds here because you need to think about that. Okay. Let's give you 3 more seconds. And let's reveal the results. I'm not sure that I actually count 10 seconds, but it might be fast 10 seconds. So I would say that most of you say D. And in fact, B is the right answer. And the problem here is that we're using C style cast. And when we use C style cast, it might be that the compiler would do the casting, but not the casting that we wanted to perform. We wanted to say, dear compiler, I think that I know that derived can be casted to a base, and I think that you understand what I want. And the compiler might say, you know what? Okay, you are a reference to derived. Let's think that you are a reference to base. But the compiler may forget or just not know that it should do something in addition. Suppose that we have here multiple inheritance. If we have multiple inheritance and derived is being derived not only from base, but also from base 1, then it means that when you cast to base, it might be that you need to move the pointer. I mean, the pointer to the base class is not exactly the pointer to the derived. You need to do, the compiler needs to do some kind of pointer arithmetics in order to move to the correct position of the base out of a few bases. Now here, the compiler doesn't know whether derived is being derived from a single base, from multiple bases. It just has an incomplete type. Now, C-style cast can work on incomplete type. And the problem is that once you have an incomplete type, the compiler just assumes. Don't assume. If we actually, in a multiple inheritance scenario, the result would be undefined behavior. I mean, we would have the casting, but the pointer would point to a bad location. In this case, the pointer would point to base 1, and I would think that I'm base, and the results are undefined behavior. The moral here, don't use C-style casting. In this case, static cast or dynamic cast, most probably static cast. Now, static cast would not compile. If I would use here static cast, it would not compile because static cast cannot work on incomplete type. And then I would fix it because I would say, oh yeah, compiler, you're right. You must know how derived looks. You cannot perform the casting well just by knowing that there is a class called derived. It's not enough information. But with C-style cast, the compiler does perform the casting, but without the proper information. So at the end, it might become a runtime bad casting, which is undefined behavior. Okay, let's go to the next one. I have a using meters equals double. I mean, when you say meters, I mean double. And then I have a meters distance of 7.5. And then I could do something with distance. And the answer of what can go wrong here relates to the Mars climate orbit that crashed on Mars. Maybe some measurement units can get wrong, or maybe I'm casting from double to int and float, int or float, maybe no type enforcement, or maybe all the above. Let's give you 5 seconds because it's easy. What's the problem here? I'm creating meters. Meters is double. I'm sending you meters. And the problem is maybe measurement units can get wrong here, or maybe I have problem with casting, or I may have problem, or maybe I have a problem with a type not enforcing the actual type. all the above. Let's see the results. And the results say mostly C, but the problem is all the above. Let me explain. When you say that meters is double using a using statement, you actually don't say much, because it means that, well, actually I can give you a distance and send it to a function that gets integer, and then the half is being truncated, and I don't know, maybe I get a warning, maybe not. Actually, maybe I'm sending distance to a function that expects feet. I thought the function being expecting a meter or meters, but nothing says that meters is not double, and maybe feet is also double. So using is just an alias. There is no type enforcement. The measurement unit can get wrong, and all sort of casting can be made. By the way, the Mars orbiter crashed on Mars because of bad conversion between meter system, the metric system, to imperial to feet, and in some scenario where the measurement units were not right. And the way to do that correctly, here is the problem. You can see the problem here. Suppose I would do something that expects a distance in feet. It would compile even if I send meters. Nobody would tell me, oh, but this one is feet and you sent meters. Well, they are both double. Double is just a number. Double doesn't carry with itself the measurement unit. And I want to carry the measurement unit with the variable. So in order to achieve that, like for example in Chrono, the Chrono library in the language, stud Chrono, comes with measurement units. You cannot ask me to sleep for 1. You can ask me to sleep for 1 second, 1 millisecond, 1 hour. You cannot ask me for a duration between 2 time points without getting it as a measurement unit in Chrono measurement units. So Chrono is working with actual safe types. You can do that with your own code. So to achieve that, go with, for example, named type library. This is linked to GitHub, and then you can create an actual meter. Here, a meter is not a double, it's an actual type. And if I'm saying that I'm expecting a meter, it means that you cannot send me something not a double. You actually need to create meter. And when you say, oh, I'm sending you meter, if it's feet, the bug is, I mean, upfront, but you see that. And I can also differentiate between width and height. Suppose that I see a bug that rectangle, for example, gets height for the width argument and vice versa. And in some cases, I do need two integers. But the first one, it says something, and then the second one says something else. And of course, the bug of sending them, you know, vice versa in opposite order, this is something that happens. Now, suppose that you get the 2 ints, and you say they are not ints, they actually have meaning, then you should create the meaning when you create a variable. Like in this example, you say, okay, there is width. You cannot just send me 10 meters, you should say, send me a width. So you should create a width. In this case, a width object. Now, it's not costly. Why it is not costly? Because in C++, creating a temporary is either being eliminated by the compiler or being very efficient. In this case, it would be eliminated if I want to get the other end, the actual value. So don't go with struct meters. This is a wrapper which is not a strong type. Go with actual strong types. Wrong types actually crash. There are cases that talk about that. And safe types go today with many libraries that are out there. Look for strong types. Let's go for the next one. What's the problem with this one? So we have an int x calls foo with 0. Let's assume that foo is 0 returns maxim. Then we go with int y equals x plus 1. And then we ask whether x is less than y or not. print y is smaller or equal. I mean, yeah, it's either x is smaller or not. And the answers might be, well, the question is what would be printed? Because the problem, I can tell you that I see the problem currently. But the question is, okay, so would we see x is smaller, or would we see y smaller? Or maybe it can print anything? Or maybe code doesn't compile? What do you say? I would, of course, emphasize that in this case, x gets the value of max int, which means that if I add 1 to max int, it cannot be bigger than max int. So something happens here at this line. And then if something happens here, I mean, I just increased beyond the max int. Oh, so y would be, I don't know, how should it affect the printout? Let's give you 5 seconds. 4, 2. And in a moment, we would reveal the results. What do you think? What do you think? So most of you say that y is smaller, but the actual answer is that it can print anything. And the result that it can print anything, C, is that because the compiler can assume, you know that, I should tell you that signed integers overflow or underflow, signed variables, signed integers overflow or underflow is undefined, which means the compiler assumes that an integer would not overflow. If it does overflow, it may go to the minimal int, but it may not. I mean, it depends on the way the compiler sees that. And actually, I can compile it with 2 different compiling flags on the same compiler and achieve different results, which is, you know, the result of undefined behavior. If you have undefined behavior, you can expect anything. I mean, it can in a way behave in a certain way when you compile it with debug flag, and then with release behave differently, and you don't want that. So don't overflow signed integers. Unsigned, by the way, is okay. If you overflow an unsigned, you go back to 0, which is okay. But signed, oh, this is undefined behavior. So the answer is it can print anything. Now printing, well, printing. But suppose that you actually got a real decision here. Well, the decision might be right or wrong, I don't know. Okay, so don't assume that signed integer can overflow. The compiler assumes it cannot. You can read about that in all these links and how to avoid that and how to deal with that. You can read more about safe numerics, because eventually you may say, but how can I deal with something that might overflow? Oh, you have to check that it does not overflow. So there are many links here. I think, Jim, that we would, in a way, share the presentation, right? So anybody here would get the link, and you can go over there, over the slides.
Yep, we'll put a link to the presentation in the description for the video.
Many CppCon talks about undefined behavior. So if you want to learn more about undefined behavior, you can pick your talk, and there are many of them. Okay, next one. What's wrong here? We are getting close to the end, if you wonder. We have here a push function in a stack. We implemented our own stack. The stack uses vector inside, and we have here a push that gets a TWREF, and then we use stood forward in order to forward the actual T that we got. What's wrong here? And the answers are, well, the first one, TWREF in push is not a forwarding reference, thus compilation error. Or B says TWREF push is not a forwarding reference, thus we support only push of R values. C says that push may add to the vector a dangling reference. And D says that push may inefficiently copy when it can move an item into the vector. So all answers say that there is some problem with T double ref. What is the problem with this T double ref here? Is it A, B, C, or D? I would give you 10 seconds, or maybe more. You need to read the answers. There are some subtle differences here that you want to take a look at. So let's give you 20 seconds. What's the problem with this T double ref? We have 20 questions overall. So let's review the results. I'm not sure that I actually gave you 20 seconds, but maybe 15. Most of you say A. Some of you say C and D, okay? And the actual answer is B. Nobody said B. Well, the problem is that T double ref is not a folding reference. Why? A folding reference is on a template argument which is attached with the template provided for the function. Now, T is not provided for the function, it's provided for the class. So T, when you call push, is already known. And once you already know that T is, for example, string, then it means you get here an R value string. Now, if I expect here R value string, it means that I do not support push for L value because I don't expect L value. I mean, I only implemented something that can take actual R value. This is not folding reference. Why? Because the T does not belong to a template parameter of this function. It belongs to something that is already known by now. So it would work, but only with actual R values. If you want to make it work the proper way, add additional one. This one should move. Why? Because I know it's an R value. Add another one for the L value case. Yes, this is the proper way. Okay, another way is to say, you know what, I want to create one. Here, the double ref is actually folding reference. Why? Because the actual template argument belongs to this function. Okay, next one. Same stack. But now we look at pop. Pop wants to pop something from the stack. So we call back in order to get the value. Now back doesn't pop. Back just gets the value and that's it. And then we call pop back. Pop back just, pops out the value without returning it. This is how it works. It just eliminates it from the vector. And then we stood move E. What's the problem here? And the answers are pop returns a dangling reference. Oh, we are returning a dangling reference. Oh, pop moves from a dangling reference. Oh, pop as undefined behavior. Moving out from a vector is impossible. You cannot do that. You cannot pop with a move. Or D, the reference E is being invalidated once we call pop back. What is the problem? Let's vote. Something is wrong in the implementation of pop. What's the problem? Maybe the problem is with a move. If I eliminate the move, maybe it's okay. And then it means, oh, maybe B. So there are some differences between the answers. They all say, oh, we are doing something better. Let's give you 5 more seconds. You can guess. You can count your answers if they are right, even if you guess. Because, it's intuition. Intuition is valid. And most of you say D. Some of you say N, A, and C. And the answer is D. The answer is D because the reference E is fine until you pop back. Once you pop back, the reference E become invalidated because, oh, I just referenced something that, oh, pop back deleted. Oops, the problem is here. Okay, so how can I do it correctly? The proper way to do is to call back stud move to a value, then call pop back. Okay, I delete something, but I do not delete E because I got E as a value and in a mostly efficient way because I moved it. Why could I move it? Because I know that you are going to pop back in a moment and then I return E. Now returning E here doesn't require calling stud move because when you return a local variable, returning a local variable has an implicit move behavior. This is the proper way. Call stud move, take my value, then pop back, then return. Okay, next one. What's the problem here? I have a conditional assign, and the conditional assign get a condition, and then it gets A1 and A2. If the condition is right, I assign A2 to A1, otherwise I do not. And I have a B, and B is derived from A, and I call conditional assign, should assign, I mean, this is true, yeah, true. This should be evaluated to true, and I send you B, and on the other side, I send another B. By the way, this is a temporary, which is okay because it's a constraint, and this is not a temporary, which is okay. Yeah, I expect an L value, and you are an L value. What's the problem? And the answers are potentially wrong method call. Oh, you would not call the one that you want. Why? Or potentially dangling reference, or potential self-assignment, or potential infinite recursion. What's the problem? I think that we might overrun a bit. We might, but we would go for the entire 20 questions, even if we are overrunning by a few minutes. So let's give you 10 seconds for this one. What's the problem? I'm calling conditional assign, and would I go to a infinite recursion maybe? Or dangling reference? Or any of the others? Okay, let's view the results. And the results, nobody says A. Most of you say B, but there are votes also for C and D, and the answer is A. The answer is A because the potentially wrong method call here is that when we call the assignment and we think that we call assignment of B, it might be that we call assignment of A. I mean, most probably we call assignment of A. You know that the default assignment is non-virtual. And usually, even when we do implement assignment, usually we do not implement assignment as a virtual function, which means that since A is of type A, we would call assignment of A, which means that even though B is being sent here, the call is not polymorphic, which means that there would be some kind of slicing. I mean, you would assign only the A part. Suppose that here we have 1, 1 and 2, 2. Only the A part, suppose that the A part is only the first int, then B would be 2, 1. A, why did you assign only the first one? Oh, because I went to the assignment of A instead of going to the assignment of B. So be aware, not everything is polymorphic. If your type didn't implement assignment or implement assignment without virtual, which is the probable case, this is not polymorphic. Let's go for, and the explanation is in this slide. Beware of slicing in general, because eventually what we got there is a bit of a slicing scenario. I'm talking about slicing in these slides, which add the skip, I think. Yeah, they all add the skip. Yes, that's good. Okay, so what's wrong here? I have class A, which holds a B with a short pointer, and a class B, which holds A with a short pointer. I mean, oh, I want to hold you. Yes, and I want to hold you back. Oh, potentially memory leak, or inefficient design, or potential infinite recursion, or code doesn't compile. Let's vote. Almost last chance to get your points, and we would count your points, and we would grade you. So it's not just a game; you would get a grade. I mean, anybody gets his grade back home, tells back his spouse, oh, I got this grade in this game. Let's give you 5 seconds. I mean, the code is quite short. 3, 2, 1. Let's see the results. And nobody says D. Yeah, the code compiles. That's right. And the problem is A. We have here a potential memory leak. And the reason is that once two types hold each other with a shared pointer, they would not die because the shared pointer increases the reference counter and both would hold each other infinitely. I mean, till the process ends. And I think most of you know that the solution for that is to use weak PTR. So I will not discuss it here, but you cannot hold a cycle of shared PTRs holding each other. It does not work well with 2 or with 3 or with 4. I mean, if A holds B, B holds C, C, D, and D holds back A, same issue. One of them should hold a weak PTR. Okay, last one. Last chance to get points. Are you ready? Let's go for that. What's wrong here? We have a function getting a Godzilla as a const reference. In the main, we are creating a Godzilla. And we call some kind of thread which says, okay, let's call function with our Godzilla. I mean, I want to call the function in a thread. This is the way to create the thread and to send to the thread the function that we want to run in the thread being spawned and the argument to be sent into the callable function, into the function in the thread. The answers are, and the problem is in this line. And the answers are, you have a potential memory leak or redundant copying or creating an unjoinable thread or thread is not copyable. What is the problem? It's quite a short code snippet. So we would give you 10 seconds. 8, 5. Let's take a look. The thread, what's the problem with the thread here? What do you say? Okay, so most of you say B, redundant copying, and you are right. The redundant copying here is because when you send something to a reference in a thread, it is not actually being sent as a reference. It is being copied. Now, since I get it as a const ref is able to take a temporary copy. So it would compile, but we would have a redundant copy here. And the way to fix that is quite simple. Instead of sending G, you just have to send stref of G. I mean, you have to wrap it as an actual reference. And it is only because I'm sending it to a thread. Otherwise, if it was a direct call, no problem. But when you create a thread, the thread decay the actual parameter, which means, oh, if it is a reference, I would create a value. Okay, are we ready? Did you count your points? Let's go through a score summary. Anybody of you got 18 to 20 points? Let's see what does it mean. Well, it means that you probably wrote so many bugs, which made you the real C++ pro you are. Ask for a raise, you deserve it. If you got 12 to 17 points, that's good enough. You're good. Remember that Bjorn rates himself 7 out of 10 in C++? Yes, he actually said that in an interview. He was asked, how would you rate yourself, how would you grade yourself in C++? And he said, I think I'm 7 out of 10. And he is a genius in C++. He knows everything. But, okay, so you are good as well. Oh, 6 to 11 points. Well, you are a bit rusty. Consider moving to Rust. If you got 0 to 5, then it means that, well, you don't have to feel too bad, but be sure to get your code reviewed, especially if you're working on life-critical systems. That's it for today. Thank you all. I really enjoy going. I gave this presentation a few times, and anytime I'm giving it again, going through the same issues. I mean, these issues, when you go through your code, you would find them. And the way to think is, okay, I saw things today. How can I avoid these issues? What should I look for? I think this is the moral from today. Any questions or comments, you can put in the chat or ask in the QA. We would stay with you a bit more, right, Jim? If there are any questions.
Yep, I'm watching. You can click the raise your hand button too if you'd like to come off and ask Amir any questions. I don't see any in the Q&A or in the chat. We'll keep it open for just another few seconds here to see if anybody has anything they'd like to ask. By the way, I did get 0 out of 5, Amir, so maybe we can start a tutoring session after this.
It means, you know, since by chance, I think we're 20, so I think that by chance you should have average of 5, right?
Yeah, I should have at least 5, right?
Not at least, but you know, around 5. So it means that either you're very lucky in other, you know, other parts of your life. It says, I think there is a something saying, an idiom saying that if you do not have luck in games, you have luck with love, something like that. So I hope that, you know, in that domain.
I think I do. All right. I do see a question.
Yeah, we have something in the chat.
Oh, he just says great.
Yeah, it's a thank you
very much.
Thank you too.
Yeah. Thank you all. Thank you all for attending. Amir, thank you again for leading this talk with everybody. We'll have a recording up in the next week or so. Our next Level Up with Incredibuild webinar will be in April. If you have any topics you'd like us to cover, whether it's C++ related or Incredibuild related, or anything else you think that might help you, let us know. You can always find me in the forum. You should have my email address as well, but I'll make sure everybody has that too. So thank you again, everyone, for attending. Thank you, Amir. Have a great rest of the day.
Bye-bye. See you all.